going to give a fairly broad overview of the livestock sector, the global livestock sector, where it is now, where it's going, and how it's likely to get there. I'd like first to just acknowledge my co-authors on this, two of whom will be speaking later this morning, Willie and Marius, but I have other colleagues from Oxford, from University of Brussels, from ILRI and from FAO who are involved in this work. So I'll start with a very quick overview of the global livestock sector and then look explicitly at the links between livestock and health, talk about some of the trends and the drivers in the livestock sector and what we do to map livestock distributions and production systems. I'll then very briefly skip through some applications of these maps for targeting and impact assessment, and mention some ways in which we disseminate the data and a few comments then on the outlook for measuring progress. So the first thing to mention about it's massive, it's really, really big, and these numbers you can see for yourself are quite impressive. And this little graphic here, which was pulled off the internet, puts it in some perspective. The darker dots in the middle represent the mass of humans on the planet. That big moon-shaped part on the left there is cattle, and then the others, pigs, goats, sheep, and horses make up the rest. So you can see, and that doesn't include the 30 billion or so poultry that are on the planet at any one time. So it's a vast, vast biomass. And one can only begin to speculate at the quantity and the diversity of pathogens that exist and evolve within those livestock. It's a massive user of natural resources as well. 30% of the land surface area is attributed to the livestock sector. 70% of all agricultural land, that is. So it's a very big thing, very big part of the way in which the planet functions nowadays. And it can't be treated in isolation, of course. It sits there at the nexus of these three global public goods of poverty and growth, health and nutrition, and climate and natural resource use. And the livestock sector influences each of those, and each of those things influences the livestock sector, and those are all completely interlinked in complex ways themselves. So, yeah, and this, I think, is really the centre of the whole One Health approach to dealing with diseases, and it's an important part of looking at the sector. Nothing can really be treated sensibly in isolation from the rest of it. Now, looking explicitly at the links between the livestock sector, or between livestock and health, there are some very direct effects, and there are some less direct effects. Poverty and climate change, for example, are very much related to health. The livestock sector contributes a massive amount to people's livelihoods. There is approaching 1 billion poor livestock keepers in the world who are very dependent on livestock for nutrition. It's an enormously important role in mixed farming and productivity and profitability of farming. So that's all linked to health as well. Poor people tend to be less healthy than wealthy people. And there are lots of indirect climate change links. The livestock sector emits some 15% of all anthropogenic greenhouse gas emissions. There are very direct things like heat waves, floods and droughts that cause ill health. But the whole thing about climate change affecting people's food security and farming productivity, it's all linked to health. So none of these things can be separated, really. But looking more specifically at the direct links between livestock and health, it's estimated, this is from a recent report by Delia Grace, a colleague of mine at ILRI, who was putting forward a business case for One Health, and she estimates that more than 2 billion people are sickened each year from the food they eat, and that millions more die from zoonotic diseases that emerge or persist in agricultural ecosystems. And diseases recently emerged from animals apparently make up 25%, so that's a quarter of all infectious disease burden in the least developed countries. And they kill 1 in 10 people who live there. So these are very significant direct effects, and these are things that we can do something about as well. And then we have nutrition, which is this double-edged sword, whereby on the one hand, 17% of calories and 26% of protein comes from livestock, They provide extremely valuable micronutrients to the poor, and we live in a poor where approaching 1 billion people are hungry and a staggering 165 million children are stunted. So we have that on the one hand, and livestock are very, very important to those people. Then on the other hand, we have growing problems with obesity and overweight and all of the health diseases, the cardiovascular disease and so on, that are associated with overeating in the more affluent sectors of society. So we have this double-edged sword, and this sort of reminds us of the importance of separating out different production systems, because it's the industrial systems that are feeding into these health problems in the wealthier people, but it's the extensive systems which are sustaining health in the poorer sectors of society. So livestock sector key to both of these things, both sides of that coin. So looking back at the sort of inclusive livestock sector there as I present it, and that doesn't occur in isolation, it occurs amidst all of these other drivers: climate change, population growth, urbanisation, changing diets, increasing wealth, energy prices, feed prices. All of these things are shifting around in complex ways and influencing how the sector evolves. Population growth is a critical factor in that. We're at 7 billion people now, and the recent projections are suggesting 9.5 billion in 2050 and up to 11 billion or so by the turn of the century. Urbanisation is an important driver. These are some projections and statistics from Nairobi, where I'm from, and it's estimated that by 2050, approaching half of the population will be living in urban areas in Kenya. So that's quite dramatic, and a lot of that depends, and the influence of that depends very much on how that happens. Are people moving into slums, or is it more affluent? And there are massive implications for livestock production for that, because these people are moving away from producing their own livestock to a situation where they're buying livestock products. And then GDP, increasing wealth, is another important driver. These are the three really big drivers of livestock production, consumption and production. And in the developing world particularly, increases in wealth is leading to much higher levels of livestock consumption, and that's driving production. And this is from the Livestock in the Balance report of FAO some time ago. And along the bottom we have per capita GDP and per capita meat consumption in kilograms per year in 2005. And this illustrates this trend of the wealthier countries eating more livestock products. And then that same thing can be seen if you're projecting the wealth of a particular nation. As they become more wealthy, there's more consumption of animal source foods. Now, I don't have time to go into the details, but this table here shows the outcome of some work we did in projecting demand for animal source foods to 2030. And I've just circled some of the big numbers. It's quite clear here that the main growth is in milk, pork and poultry, and also that the main growth is in Asia and Southeast Asia. Now, these figures have been reduced a little bit, but these some very dramatic percentage increases in consumption of poultry meat in India in particular, which are going to be driving livestock production, the development of the livestock sector there. There's a very clear pattern whereby developing countries are advancing much more quickly than developed countries. And the way in which this demand happens determines the way in which the sector will respond. So this graph here shows per capita consumption along the bottom. It's for poultry meat in China, and population growth up the side. Now, the purple area here, this shows the area of this square here shows demand in 2000. And if population were only to grow, we would have that 11% increase in demand above there. But if it was just per capita consumption, we would have this 78% increase along the horizontal axis. Now, per capita population growth is just more of the same. It's the same people producing, just more people producing more meat and so on. But when you have consumption changes, this requires structural changes in the livestock sector. And these structural changes are very important because they have very important health implications. So rural population growth leads to expansion, but urban population growth, increasing wealth, and changing consumption patterns results in intensification of production. So summing up that so far, we have these demographic and social drivers: population, income growth, and urbanisation. These are pushing up demand for animal source foods, particularly in the developing world. And these are resulting in structural changes in the livestock sector, shifts from ruminants to monogastric species, vertical integration of production, intensification of production, separation of livestock production from the land base on which it requires for feed. These are all factors that are dealt with, these are all characteristics of intensification. And this impinges on these global public goods of poverty and growth, climate, natural resources, and health and nutrition. And this calls for an integrated approach to socially desirable livestock sector outcomes, and that requires reliable data and information to guide policies. So I'm going to just now scan over the work that we've been doing to map livestock and livestock production systems. We start with subnational livestock data, which we gather from various sources. We have procedures for livestock distribution modelling based on multivariate statistical analyses, and we produce global livestock density maps. We then have production systems modelling approaches, which helps us to disaggregate those livestock into different production systems. And then we have herd and production modelling, whereby we can estimate the outputs and the product produced in those different systems. These are examples of some our most recent maps of livestock densities. They're 1 kilometre global maps. This shows pigs, chickens, ducks for Asia, and that's just an example showing the global cattle distribution. So these we've produced recently, and they're based on updated techniques from earlier methods. And I'll just illustrate the production system mapping with looking at the chicken sector, monogastric production systems. So we start on the left-hand side with our livestock distribution map, and then we estimate the proportion of those livestock that are held in backyard systems compared to intensive systems. And we share out the backyard poultry amongst the agricultural rural population, and then the difference between that backyard production and the overall production we assume to be industrial production. Now, an important part of this is it's linked very much to mapping agricultural populations, but an important thing as well is to try and find data or find ways of predicting the proportion of backyard chickens or pigs in as opposed to intensive systems. These data are available, estimates of this are available for some countries, but only for very few countries. Now each spot on there is a different country, and that shows the relationship between GDP, per capita GDP, and between output and input ratios of livestock, which is productivity. It's basically how many kilograms you get of produce per standing stock. So there's a relationship there that looks like we might be able to base something on it. And we can. So what we do is we have log per capita GDP along the bottom there, and the proportion of extensively raised chickens, and we use that relationship there to estimate the proportion of extensively raised chickens in areas where we don't have records, because we do have estimates of log per capita GDP for all countries in the world. So we apply that to countries where we don't have those proportions, and then we map out extensive versus intensive production in this way. And the nice thing about that is that it enables us to predict what's going to happen in the future, because we have projections of GDP, shaky as they may be, but they are projected into the future, and we have systematic ways of estimating that. So this is just taking an example, reading off the value for China here. In 2000, that's there's 2.9% log per capita GDP. Sorry, $2.9 log per capita GDP there, and the proportion of extensive production is about 83%. 30 years on, the projections suggest that the log of per capita GDP would be $3.8 per person, and so we would expect the proportion of extensive production to have reduced dramatically down to about 18%. So we can project for different countries how we expect the sector to change, and then we can infer the sorts of implications that result in. Now, very quickly, I'm going to just flash through a few slides. I don't need to go into any details here because Marius and Willie and David will be talking in details about some of these things. But the applications of these maps in terms of monitoring and evaluation, targeting and impact assessment, we've used them successfully to predict disease risk, H5N1 risk. The duck map was a very important contributor to that. It's an important contributor to Rift Valley fever maps, for example. This is some niche modelling work that we've been doing in Kenya recently. The black spots show existing observed outbreaks, and the red, the darker the red, shows the higher risk of the higher probability of that occurring. We've used them to estimate the economic impacts of diseases as well, to quantify the benefits of disease control, and Willie's going to be talking about that later on. And a relatively new application, which is quite important, is in looking at antimicrobial resistance. And this is some work done by a colleague of ours, Thomas van Berkel, and he's been looking at collecting data on antibiotic use in the livestock sector along for different species and for different production systems. It's fairly sparse data, but we've been gathering that together and applying that to the livestock distribution maps in order to estimate antimicrobial usage in food animals. And this is going to have important implications in the future. So that's a nice new application that's coming up. Data dissemination. We've developed this livestock GeoWiki, which is what we use to disseminate the data. And the data are all freely accessible from this. And we have a central module on production and production systems, and then we have side modules on health, environment, and economics. So finally, looking forward, there are important improvements that we can make to the livestock maps themselves, and this is an ongoing process, and we're working on this. There's a lot of work we can do to continue to better disaggregate these livestock into their different production systems, and to gain better understandings of the key drivers, population, wealth, urbanisation, and how these are going to shape the livestock sector of the future. So then the question becomes, how will these evolving livestock sector affect livelihoods, equality, and the environment and public health? And then when we have these analyses in hand, the next question then becomes how we can translate this body of evidence into actionable policies to guide sector development.